What's up, everyone? What if your Payload CMS was your analytics app? Today, I'll be wiring Plausible into Payload CMS using route handlers to create a custom admin view with Recharts so your key data lives where you work. I'll be building a sleek, modern dashboard within my Payload CMS admin UI using Payload CMS UI components and styles. By the end of this video, you'll understand how to query your data using route handlers and render it on the front end using custom views and navigation link components in Payload. If you want the code I use in this video, there's a link to the repo in the description. Now, let's dive in. Before we get started, you'll want to make sure you have an analytics provider and the API key associated to your data. All the major analytics providers, including Google Analytics, provides this for you, but each analytics provider is different in how they provide the information. I'll be using Plausible Analytics with my own self-hosted account. I only need my API key and my analytics host, which I've stored in my environment variables. While this video will use Plausible Analytics, it is not a Plausible Analytics tutorial. The concepts we cover here should apply to any variety of analytics provider that you'd like to integrate with. To ensure all of our data comes through exactly like we expect it to, we're going to use Zod for validation. So I'm going to install that by running pnpm add Zod. And with that installed, we're going to come to our source directory and we're going to add a new directory that's just going to be called lib, L-I-B, short for library, and then we're going to create a plausible.ts file inside it. So I will create that file, and here in the file, we're going to import Z from Zod. There are a couple of pieces of data that we want to be ready to take. So the first one is going to be our constant of time period schema. And we're going to have this be an object from Zod, which will have a date, which will be a string, visitors, which will be a number, page views, which will be an optional number, our bounce rate, which we're going to use snake case to match what we get from Plausible itself. So we'll have bounce rate, which will also be an optional number. And then finally, visit duration, also in snake case, which will be a number and optional. We'll move on to another constant called page schema, which will be another object, which will take the page, which will be a string, our visitors, which will be a number, page views, also a number, but this time not optional. Again, our bounce rate, and then again, our visit duration. We'll get our source schema, again, an object with source, visitors, bounce rate, and visit duration. Underneath that, we will create another new constant called event schema, again, an object, with our goal being a string, visitors a number, events another number, and then conversion rate, which will also be a number. Now we need a results object, so we're going to set a schema called stats schema, which will again be an object, and we'll get our results, which will be an object inside of that object. We'll have our visitors, which will be another object. This will have a value, which will be a number, and then the change, which will be a number, will be nullable and is optional. And visitors itself is also optional. Then we'll have our page views, which is expecting an object, again, of value and change, which will be exactly the same, and this will also be optional. Below this, we'll have our bounce rate, which will also expect a value and a change, and then will also be optional. And then finally, our visit duration will be a value of number, and then a change of nullable, optional number. This will be optional, and then finally, everything will be optional. Plausible does have real-time data that pipes in, so we'll set our real-time schema to just be a number, so Z number. Then we can export some types, so we'll export a type called time period data, which will infer the type of the time period schema to set the type. We'll do the same for our page data. We'll do it again for our source, and then finally our event data. And then we'll define our stats data type a little bit differently. So we'll set stats data equal to an object of visitors, which will have a value of number and a change of number or null, but we won't have null there. So page views. Then we'll have page views, which will do the same thing, bounce rate, and then finally visit duration. Now we'll set a plausible data interface. So we'll export this interface called plausible data. Then we'll get our stats, which will be stats data, our time series, which will be a time period data as an array, our pages, which will be a page data array, sources, which will be a source data array, events, event data array, and then our real time, which will just be visitors number. And that's it for our Zod schema. Now we can get started on setting up the actual data fetch. But before we do that, I'm going to go up to the top of my file here and create a new function called getPlausibleConfig. This is optional, but it is convenient. It's going to make things a little bit easier. So I'm going to return our API key, which is our environment variable of plausible API key, and then site ID, which is our environment variable of next public plausible domain. And then finally, our API host, which will be our environment variable of plausible API host with a fallback of our environment variable of next plausible host. And then lastly, the actual plausible.io API endpoint for the hosted version of Plausible. Now, I've already included each of these in my environment variable, and I do have an environment variable example file that is included in the repo that you can use to get started with the proper environment variables. Now we're going to go below all of our Zod schema, and I'm going to create some space here. Now up here, I'm going to create a new async function called fetch plausible API, which will be a generic, and this will be a function. And for our arguments, we'll expect an endpoint, which will be a string, params, which will be a record, which expects a string in both positions, and it defaults to an empty object, and then a schema, which is going to expect a Zod schema generic with no default value. The whole thing will resolve to a promise, which will take either a generic value or a null value. Then we can set a constant called config to store our plausible config, and then we're going to try and fetch some data. So here we will try, and we'll set our query params to be new URL search params, and we'll get our site ID from our config site ID, and then pass in the rest of the params. And then we can construct our URL. So I'll have a constant called URL, which will get our config API host. Then we'll have our API version 1 stats, then endpoint, and then our query params to close that out. My site ID cannot be nullable, so I will include the non-null assertion there. Now we can store our response in a constant called response and await fetch for our URL. And in our URL, we'll pass in some headers, which will be a bearer token with our API key as the bearer token. And then we'll use our next revalidate option to revalidate every 300 seconds, which is 5 minutes. So what this is doing is it's caching the response from Plausible for 5 minutes. If our response is not okay, we can return null. Otherwise, we can await the response and get the JSON response from it, and then return our data parsed in the schema that we have set up. Now we need to catch our error E, and then we can just log it in an error and just say error fetching plausible data and log the error, and then return null. This gets us about halfway in fetching our data. Now we need to set up the function that gets the plausible data to then be rendered in our custom view. So below this function, we'll create another async function and export it. It'll be called getPlausibleData. And for an argument, we will have a period, which will be a string and will default to 7 days. And now this 7 days, the 7D string, is unique to Plausible. You may need to check your analytics provider to ensure that you're using the right keys that they're expecting for their time series. This will resolve in a promise of plausible data or null. And then again, we need to get our config that we'll store in our constant called config. And then we're going to try to get some results, and we'll just get our catch section ready to go there. We're going to get our results and store them in an array of constants, and we're going to get this from awaiting a promise all. So we are going to get our stats response, time series, pages, sources, events, and our real-time value. Now in our promise.all call, we're going to fetch the Plausible API, and we're going to check in the aggregate endpoint for the period with metrics being set to visitors, page views, these are the params that we're setting here, bounce rate, and visit duration. And then we're going to compare the previous period. And this will expect the stats schema. Now we're going to move on to our time series endpoint where we'll get the period and then the metrics of just visitors for this because we're going to be using it in a chart. And then outside of that object, we need to create a new Zod object, which will have our results, which will be an array. And that'll expect the time period schema, and we can remove that from this. Then we will get our results or fall back to an empty array. After that, we're going to fetch Plausible API for our breakdown endpoint, which will have the period as well as the properties that we want, which will be our event page. And we're going to limit this to just 10 results, which expects a string. Then we need our metrics that we want, which will be our visitors, our page views, our bounce rate, and our visit duration. Then we will create a new Zod object with the results, which will be an array, and it'll expect the page schema. Then we can process our results or fall back to an empty array. We'll do this all again for the breakdown. And instead of event page, we'll do visit source, which again will limit to 10. We'll get our visitor, we'll get our bounce rate, and we'll get our visit duration. And then we'll have this be for our source schema, but the results array will stay the same and we'll process that or fall back to an empty array. And then finally, we'll copy this all once more because we again want the breakdown endpoint for the period property, but this time the property is event goal. We'll limit it to 10. We'll get our visitors, we'll get our events, and then finally our conversion rate. Again, this will be an object that has a results array from our event schema. Then we'll process our results or catch our error, which we will set to be E, and then just provide a warning saying that we failed to fetch events and then log the error. Then we can return an empty array. Real-time visitors may not be available on all instances of Plausible, but it is for mine. So we will get our real-time visitors endpoint with an empty object and our real-time schema. Then we will pass in the response as a value for visitors or just fall back to 0. And then catch, again, our error, but with no actual error message this time, and just pass in 0 for our visitors. So we always have a value available for our real-time visitors. Below this, we will check if there is no stats response results, we will return null. But otherwise, we can get our constant of stats, which will be of type stats data. Then we can get our visitors, with the value being our stats response results visitors, if it exists, value, otherwise 0. Then our change, which will be stats response results visitors, then change, otherwise it'll be null. Then we can do the same for our page views, which again will be value, stats response results page views, if it exists, value, otherwise 0. Then again, change, which will be stats response results page views, change. If it's undefined, it'll be null instead. Then we'll do this again, and I'm just going to copy this from page views for our bounce rate. So I'll replace page views with bounce rate, and then one last time from bounce rate to visit duration, and then I need a comma right there. Then below that, we can finally return our stats, our time series, which will be time series as time period data as an array. Then our pages, which will be pages cast as page data as an array. Sources, which will be our sources as source data array. Then events, events as events data array. And then finally our real time, which will be real time or visitors 0. Then we can catch our error, which will do a console error of error fetching plausible data, and then return our error message there. Lastly, we will return null if there is an error to catch. We'll want a way to format all of these numbers in a reusable way that we can then use on the front end in the future. So let's define some of those functions here. We'll export a function called format number, which will take a number of type number, and it'll resolve to a string. And then if the number is greater than or equal to 1 million, we can return our number divided by 1 million, then fixed to 1 digit, and then add the million there. But we're actually going to interpolate this string, so I will change that formatting there, and instead of the plus, we can just include the m here. If we pass that check, but the number is greater than 1,000, we'll return our number divided by 1,000, fixed to 1 digit with the k for 1,000. Then we can return our number to string. Now let's take care of our durations. So we're going to export a function called format duration, which will take seconds, which will be a number, and will resolve to a string if seconds are less than 60. We will round our seconds, so it'll be math.round seconds into seconds. Otherwise, we'll get a constant called minutes, which will take our seconds divided by 60 and then round down. Then we will store our remaining seconds, which we'll use the modulo operator here to get the remainder. But I'm going to round this, so I'll just do math round. And now we can return something, but first we'll check that remaining seconds is greater than 0. If it is, we'll return minutes and remaining seconds. Otherwise, we'll just return our minutes. Now we can format our percentage, so we'll export a function called format percentage, which will take a value, which will be a number, and will resolve to a string, and then we'll return a math round value with a % sign at the end there. And then lastly, we need to format our change. So we'll export a function called format change, which will take a change of number or null, and will resolve to a type of text string is positive Boolean. Now in the function, we can then check if change is equal to null or change is 0. We can return our text, which will be 0%, and is positive is false. Otherwise, we can store our positive value in a constant called isPositive, which will check if change is greater than 0. Then we can set our text to check if this is positive. We can return a plus sign, otherwise an empty string, and then we can math round our change value and add a percentage to the end there. Then we can return our text and is positive from the function. The view we're creating is going to be a detailed view, so I'm going to add to my source directory a new file that will be at API analytics detailed route.ts, and we're going to import a next request as well as our next response from next server. Then we're going to import our get plausible data from our library plausible file. And what we're going to do here is we're going to set up the route handler that's allowing us to actually hit an endpoint and get data back. So we're going to export an async function called get, which will have a request, which will be of type next request. Then I'll set up a try catch statement here. And we're going to store our search params in a constant called search params, and we're going to check our next URL search params, as well as our period, which will check the period param or just return 7 days if there is none. And then we'll store our data by awaiting our get plausible data for that time period. If there is no data, we can return a next response, which will be a JSON response, and we'll get an error that says failed to fetch data from plausible, and then also a status, which will just be 500. Otherwise, we can return a next response, which will be a JSON response for our data. Then in our catch, we will do a console error that says analytics detail error, and we'll return the actual error itself. We will then return a next response, another JSON response, which will say error, and then it'll be internal server error, and then a status of 500. Since this is all just API endpoints, there's not really much to show quite yet. We are ready to start building our view now, though. We'll need to create 2 new TSX files. They'll be stored in a new directory at source components plausible view. One file will be for the client side and the other one for the server. I'll create the directory we need as well as the files by just running a simple command for make directory for the source components plausible view, and then the touch command to add our index.client.tsx and our index.tsx. So now I can open my project file and I see this new components plausible view with the 2 files that I need. Let's start with the server side of things so we can start seeing data show up. We're going to import React. From React, we'll import our default template from Payload CMS next templates. We don't need the rest of this here. Then we're going to import a few things from Payload CMS UI. First will be gutter, then the set step nav, and then a type called step nav item. Then we'll import a type called admin view server props from Payload. We can export a constant called analytics view, which will be a functional component from React. And we'll take the admin view server props. And then we can set this equal to a function. And for our props, we're going to pass in init page results, params, and our search params. Now inside the function, we need to make sure we secure this view ourselves. So we will check init page result request user. If there is no user, we can return a paragraph tag that says you must be logged in to view this page. Now, if we don't do this, anybody can access this page because it will be public. So setting it up like this, we'll first check that there is a user. If there is, they can see the view. Great. If not, there will be no view available to them, and they will just see that they must be logged in to see this view. Now, of course, you can add a login button or any other kind of information that you want to, but for now, this will do. By default, views don't contain your icon and any kind of breadcrumbs in the view. So we'll set that up using a constant called steps, which will be an array of step nav items. And we'll just include one item, which will have a URL of analytics, and then a label of analytics. We'll then return our default template, which will need our visible entities, our internationalization, our payload. It'll also need our locale, our params, our permissions, and our user. Now our visible entities will be our init page result visible entities. Our internationalization will be init page result request internationalization. Payload will be init page result rec payload. Our locale will be init page result locale. Params will just be params. Then our permissions will be init page result permissions, and our user will be, again, init page result request user or undefined. And finally, the last thing we need is our search params, which will just take the search params that we pulled out in the props here. Now, inside the template, we're going to include our step nav here, just by including our steps array. And this set step nav comes from Payload's UI library. And I'm also going to use gutter, which comes from the same place. And then we're just going to include an h1 with a style of margin 1 rem 0 2 rem. And the h1 will say analytics dashboard. And then we'll close all of that out. Then we'll export this as a default constant. And we'll run over to our payload config. And in our admin options here, we'll add a components option. In our views, we'll add an analytics view, which will have a component of our components plausible view index.tsx, and then a path of analytics. Now we'll want to run payload generate import map, and then pnpm dev to spin up our dev server. And then at the end of our admin route here, we'll add analytics. And we'll see that we just have a custom view that says analytics dashboard. We've got our step nav here, which has analytics as the breadcrumbs and a working icon back. Now, let's say that I was not logged in. So I'll turn off my auto login, and I can see that I must be logged in to view this page. But if I were to not include in our view here this little section of code, we can see that I'm not logged in, but I can still see the analytics view. So double check to make sure that you have this analytics view or any view that you want secured. So I'm going to uncomment that and restart my auto login. Now, of course, there's not much to this yet, but we have the shell that we can start filling in. But before we start working on the client side of things, check to make sure you're subscribed to my channel and receiving notifications so you never miss when I release more content about Payload CMS, Next.js, Tailwind CSS, and more. If you're tired of trying to keep up with all of the industry news happening in web development, consider subscribing to my newsletter, Next in Dev, where I'll send a bi-weekly overview of all the news I can find from across the internet that is relevant to you. There's a link to that in the description. Also consider becoming a paying member of my channel. Not only does that support me, but it allows you at certain tiers to view content before it's made available to the general public. Again, there's a link to that in the description. Thank you for your support. Now let's get back to it. Let's head on over to our index.client.tsx file. And we're going to start this off with use client since it will be a client component. And we're going to import React, as well as use effect and use state from React. We'll import a few things from our Plausible library file. The first will be format number. Then we'll also get our duration formatting, format percentage, and a type, which will be our Plausible data. We'll import our select input from Payload CMS UI, and then we're going to import type called option object, which we'll use for our date selector as well. I'll be using inline styles mostly to style this, as well as some Payload CMS styles. You can use CSS modules any way that you would normally style a nextjs app, but I'm just trying to get data showing, so I'm going to keep styles quick and easy. Now let's start building our dashboard. So I'll export a constant called analytics client, and this will be a React functional component again, and this will be set equal to a function. Now, before we get started, I can just return a fragment here, and I'm going to go over to our index.tsx file and import this below our h1 so we can see things as we go. So I'll import analytics client up here, import analytics client from our index.client. So now let's start getting our dashboard populated. First, we're going to use a couple of use state hooks. The first one is going to get and set our data. The next is going to be getting and setting our loading status. Then we'll use state for our error status. And then finally, another use state hook to get and set our time period. Our data will default to null, and we'll expect our plausible data or a null value. Our loading status will default to true. Our error status will take a string or a null value and will default to null. And then our period will default to 7 days. We want this to run on every render, so we'll use a use effect hook, and we will set a constant called fetch data to be an async function that will set loading to true. And then I'll set up a try catch statement here, and we'll store our response in a constant called response, and we'll await fetch for our API route that we set up, the detailed one. So analytics, detailed, and then we will pass in a param for our period, which will be the period there. And that means that we need to pass in that period as a dependency. So we'll check if response, not okay. We can throw a new error that says failed to fetch analytics data. Otherwise, we can store our analytics data by awaiting our JSON response and then set our data to be our analytics data. Otherwise, we can catch our error E, set our error by checking if our error is an instance of error. If it is, we'll get our error message. Otherwise, we'll just say an error occurred. And then finally, we can set loading to false. At the end of all of this, we can fetch our data. Now we can add some code, but first we'll check if loading, and if we are loading, we'll return a div that says loading analytics. If there's an error or there's no data, we can return a div that just returns the error or unable to load analytics data. Then I can make some more space down here. Below our error check, we can destructure our constant of stats, time series, pages, sources, events, and real time from our data. And then we're going to start working on our date selector. So I'm going to set some options here. So we're going to have constant of options, which will have a label of last 7 days and a value of 7D. But we're also going to have last 24 hours, which will have a value of day. Then we'll have 2 more options where we'll have one of last 30 days and last 12 months. We'll change these 7 days to be 30 days, and then finally 12 months. Now let's return some data. So we'll return a div, which will have a class name of dashboard, which comes from Payload CMS. Then we'll have another div, which will have a class name of dashboard group, again, that comes from Payload CMS, and a few inline styles, which will have display, inline block. Then we'll have our margin bottom of 1 rem. And then in our div, we'll have a select input, which will include time select for the name and the path. So time select here, and then again, time select there. Then we'll have a label, which will be time period. And then we'll set our options to our option array from above. And then we'll need our value, which will be our period. And then for on change, we will use our period here, and then set period, and we'll cast our period as an option object and get the value from that option object. Now, if you're following along, you may have noticed that I made a mistake. That mistake is that the API folder is outside of the app folder. So what I'm seeing over here on my analytics dashboard is that it failed to fetch analytics data. And that's because Next.js cannot find my API route. So if I move my API route down into my app folder and refactor, and then refresh, we can see that my time period shows up properly. So we are bypassing all of our errors, and we do see our time period. Now, when I click into the dropdown here, I can see all of my options styled nicely to match my Payload CMS. There's this X here, but I need a value here in time period. So if I come down to my select input from Payload CMS, we can actually add at the end here is clearable, and we can set that to false. When I save that, we can see in our analytics dashboard now that there is no way to clear this value. Now, underneath this, we can set another div called dashboard group, and this will have an h2 value with a class name of dashboard label, and the h2 is going to be an overview. And we'll create another div, and these will be some inline styles. We're going to be setting up our real-time indicator. So we're going to have display flex, align items will be center, then a gap of 1 rem, a margin bottom of 1 rem, and then finally a font size of 1 rem. So inside this div, we will have a span, and this span will not say visitors, but it'll have style of width of 8 pixels, a height of 8 pixels, then a border radius of 50%, and a background color, which will check if we have real-time visitors, which means that there are more than 0 real-time visitors. If so, we will return a hex value of 10B981, and these are just values that I found that I liked. And the other value is going to be 777, which will be a lighter gray. And this span can be self-closing, as this is our real-time indicator. We'll then have another span, which will return our real-time visitors. We'll then return that there are visitors unless real-time visitors is equal to 1. If it's not equal to 1, we'll return the plural version, otherwise an empty string, and then we'll add online now. And then we can save this, and we can see we have our real-time indicator here, which there are no visitors online now, and that's okay. And now I'm going to add underneath this div here an unordered list, which will have the class name of dashboard card list, and I'm going to add a margin bottom of 2 rem, and I'm going to start creating some cards to return our overview data here. But I'm going to create components for this because it's going to be the same component just with different data. I want my cards to look like how Payload has their dashboard cards, which are here, the collection cards, but they don't export that card in a way that I can use it. So I'm going to have to create my own and use some payload styles. So what I'll do is in my components directory, I'm going to create a new file, which will be called card index.tsx. And in here, we're going to import React from React, and then our format change function from our Plausible library. And then I'm going to set an interface called card props, just so it's clear what this is. Then we'll need a title, which will be a string, a value, which will also be a string, but I'll accept numbers, and then a change value, which will be optional and can also be null. We'll want to include a formatter, which we have handling the actual values itself. So I'm comfortable passing in any here. And the formatters are things like format change, format number, format visit duration, things like that. So this formatter function will accept any type for the value and will resolve to a string. And then we'll also check if positive is good, and this will be optional, and it will expect a Boolean value. Now we can export a constant called card, which will take our props of type card props, and then we'll destructure our props to get our title value change formatter, and positive is good values. And then we will set a constant called formatted value, which will check if there's a formatter. If there is, we'll format to that value. If not, we'll just return the value. Then we will store a constant called change data and include our format change value there, which will pull in the change value or a null value. And then we'll check if positive is good and store this as our constant is positive. So I can do our change data is positive. Otherwise, change data is positive, but the opposite. And so what this is doing is positive is not always good in analytics. If you have an increase in bounce rate, that is bad. So that should be shown as red. Otherwise, it should be shown as green. So we want to make sure we account for instances like that. Now we can return our list item. Then inside our list item, we'll create a div, which will have class name of card. And we'll have a style of flex direction column. And then in this, we'll have an h3, which will be our card title. And we'll pass in our title here. Then we'll have a div that has a style of font size of 2 rem, and then we'll pass in our formatted value. Then underneath that, we'll check if there's a change, and that change is not undefined. If that's the case, we will pass in a div, and that div will have a style of color is positive, and then we'll just pass in either green or red. And then in here, we can pass in our change data text from previous period. Now we can import this over in our index.client.tsx. So we'll import card from our components card. And then in our unordered list here, we will add a couple of cards. So I'm just going to pass in one card first. And this will be self-closing. So we want to get our title, which we'll have set to be visitors. Then our value, which will be a stats visitors value. And then change, which will be stats visitor change. And then our formatter will be format number. And then positive is good. So we'll set that to true. Then we'll copy this card and paste it. And we'll include our page views. And then in our page views, we will change these to be page views. We need our value, our change, and we are formatting a number again. And again, positive is good here. So again, we'll paste another card, and then we'll include our bounce rate. Then we'll change these to be bounce rate. We'll format percentage as our formatter, and positive is not good. So we'll include false there. And then one last card, we'll do our visit duration. Then we can change our visitors to be visit duration. And we are formatting our duration, and positive is good. So now I can save this, and over in our analytics dashboard, we can see our cards showing up. Let's move on to adding a chart now. So I'm going to end my development server here and install Recharts from pnpm add Recharts. And since Recharts exports everything that we need, we don't need to create any components, but you're welcome to if you would like to. So I'm going to import our x-axis, our y-axis, our Cartesian grid, our tooltip, a responsive container, the area, and area chart, all from Recharts. Now we have different time periods that need different formatting. So I'm going to set up some formatting functions ahead of our exported constant here. So the first one is going to be formatting our axis date. So I will format axis date, which will be a function, which will expect a date string, which will be a string, our period, which will also be a string, our index, which will be optional and is a number, then our total, which is also optional and will be a number. All of this, though, will resolve to a string. We'll get our date, which will be a new date from our date string. If our period is equal to day, we're going to return our date to locale time string. I'm going to use the English US locale, and hour will be numeric. We will not include minute, but we will use hour 12 and set that to true. So this sets it to 12-hour time instead of 24-hour time. And now up here I see I have a typo. I'll change that from total to title. Else if our period is 12 months, we will get our month from our date and store it in a constant called month. And then if month is equal to 0, that means it's January. We're going to return our date to locale date string. Again, we're going to use the English US locale. And we will just include month, which will be short. Then we will have our year for just January, which will be our 2-digit year. Otherwise, in this case, we'll just return our toLocale date string without the year, and it'll just be the short month value. Else if, we'll check then again that period is equal to 30 days. If it is, we'll return our date to locale date string, English US locale. Month will be numeric, and then day will also be numeric. For the last case, which was everything else, we will return our date to locale string. It'll be, again, English US locale. The month will be numeric, the day numeric, and year will be 2-digit. We'll also need to format a few things for our tooltip. So I'll create a function called format tooltip date, which will take a date string, which will be a string, then a period, which will be also a string, and then this will all resolve to a string. Then we'll store our date in a constant called date, so we need a new date from our date string. Then we'll check if period is equal to day. We can show the full date and time, so we'll return a date to locale date string for the English US locale. Month will be short. Day will be numeric. And then our year will also be numeric. And I'll exclude our hour 12 from this return statement as well. I'll then concatenate a few things. I'll say at, and then we're going to add date locale time string, and we're going to add the hour and then hour 12 there. Else, so for all other cases, we'll return our date to locale date string for the English US locale. Our month will be short, day numeric, and year also numeric. Now we can go and create a new dashboard group underneath our cards. So underneath the unordered list here, we can create a div, which will have a class name of dashboard group, and then a style, again, of margin, and we'll just do 002 rem. And then inside this div, we'll have an h3 that will have a style of margin bottom of 2 rem. And the h3 will say visitors over time. And now I can check if our time series length is greater than 0. And if it is, we will return our responsive container of width 100% and a height of, I prefer 250 here. Then we need our area chart, which will take our time series as data. And now time series is an object of both a date and a value of our visitors. So that's how we're going to be getting our data into a chart. Then we're going to have a margin of top 0, right 0, then left of -40, and bottom 0. And then we need to set some definitions here. So we will set our defs element, and then we're going to have a linear gradient, which will have an ID of color visitors. Then we'll have an x1, y1, x2 of 0, and then y2 of 1. And then we'll set a couple of stops in our linear gradient. So I need 2 stops. The first stop is going to offset by 5% for our color here, and the opacity is going to be 30%. And then in the other stop, we'll offset by 95%, the same color stop, and then stop opacity of 0.05. Then we'll close out the linear gradient and the defs element. Then we need our Cartesian grid. So we'll include that here. And that is self-closing, so I'll close that. But we need a stroke dash array, which I'll set to just be 5 by 5. And then our stroke is going to be a payload CMS variable, which will be our theme elevation 200. Underneath this, we need our x-axis, and we need our data key of date. And so what this is doing is it's passing in a key into our time series object, and it's looking for the date key in our time series. So that means that our x-axis is going to be our date. And so we'll see here in a minute that the x-axis will include all of the dates and times that we need. So then underneath our data key, we need also a few other things like our tick formatter, which is a function of value and index. And then we're going to format our axis date with value period index, as well as our time series length. Then for our tick itself, we're going to set a fill to be another payload CMS variable of theme elevation, and we'll set it to the 600 shade of that. Then we need a stroke, which will be another variable of theme elevation. We'll use 500. Then we need a style, font size of 0.75 rem, and then we're going to set an interval of preserve, start, and end. Now we can start working on the y-axis. So I'll pass that in, again, self-closing, and we'll use a stroke here, which will again be variable theme elevation 500. Tick will be fill variable of theme elevation 600. Then we need a tick formatter of our format number, and we'll include another style tag, and we'll include another style attribute of font size 0.75 rem. Now you'll notice that we're not using data key here, and that's because we'll set it in the actual chart. You'll see what I mean here in just a minute. Underneath our y-axis, we're going to include a tooltip. And our tooltip, again, is self-closing, and we're going to have a few things here. We're going to first start with our styles, which will be a background color of theme elevation. We'll do 50, and then we'll need a border radius of 0.25 rem. We'll do a border then of 1 pixel solid variable theme elevation 200, and then we'll need a color, which will be variable theme text dark. Then our padding, which will be 8 pixels by 12 pixels. Then we need a font size of 0.875 rem and a box shadow of 0, 2 pixels, 8 pixels. And then we're going to use an RGBA value of 000, so black, with an opacity of 10%. Now we need a label style, which will have a color of variable theme text light, and then margin bottom of 0.25 rem. Then we'll need to set an item style, and then we'll set a color of variable theme dark, then a label formatter, which will be a function which will take the label and format the tooltip date based on the label and the period. And then finally a formatter, which will take a value of number. And this value will be passed in as an array to be format number value visitors. And then lastly, we need a separator, which will just pass in an empty string. Now we can actually render the chart. So we need to use the area for that. The data key, which I mentioned earlier, is the visitors. So just as a recap, this data key is being passed into our time series object here. So the time series object has date for each item and visitors for each item. So now we're just getting the visitors out of that. We're going to set type to be monotone, but there are other options here. I just like how monotone looked. We'll set a stroke to be our green color that I have, 10B981. And then we need a fill of our color visitors, which is set up here in our definitions. So our linear gradient, ID color visitors. And then we have a fill opacity we'll set to be 1, and then a stroke width to be 2. Otherwise, we can say that no data available for this period. So now I can save this, and over in our analytics dashboard, we'll need to first run pnpm dev, and I can refresh. And now we see this very nice chart down here, and I can see that the tooltip is missing some padding, and it's because I have a typo right here. So I'll set that to 8 pixels by 12, and now I can see that the tooltip looks much better. I can now change my time period to last 30 days, for example, and then last 12 months. And so you can also see that our x-axis is changing as we make adjustments as well. So now things are looking pretty good, but I also have some more data that I can put into tables. Now again, the Payload CMS tables are a little difficult to work with, so I'm going to create my own table components and import them into this file. So the first thing we need to do is in our components directory, add a new directory, which will be called table, and then I'll create a file inside of it called index.tsx, and I'll create that file. And we're just going to go straight into exporting a constant called table and set that equal to a type of generic, which extends the record type, which will take a string and then any type. For our props, we'll take columns, rows, and a title. And then our types for that, we'll have a columns type, which will be an array, which will have a key, which will be key of generic, a label, which will be a string, and then an optional formatter, which again, we can pass in any value because we know that our formatters are actually handling the value check. Either way, it'll resolve to a string. Then we'll have our rows, which will be an array of generic, and then a title, which will also be a string, and this is actually required. Now we can, in our function, return a div, and the div will have a class name of collection list tables, and I'll include styles of margin bottom of 2 rem to add some spacing. And then in this div, we'll have another div, which will be a class name, and that'll be table wrap. And in this div, we'll have an h3 that'll say our title. And the h3 will have a style of margin bottom of 1 rem. Then we're going to have a div that will have a class name of table, and this is where we're actually going to have our table. So I'll pass in a table element, which will have a cell padding of 0 and a cell spacing of 0. Then inside the table, we'll have our table head and we'll have our table row inside that. So our table row will have our columns. So I'm going to do columns map. And then in here, we're going to pass a function, which will pull out our column and our index. And then we will have a table header of key index. And the table header will be our column label. And then underneath our table head, we'll have our table body. And here we're going to map our rows, which will have a row and an index. And again, our table rows here will have a key of index, and then we'll need a class name of row, and then we'll include our index. And since it's 0 indexed, we'll include +1. And I'll do the right index here. And then for each row, we're going to map our columns, which will have a column index, and we can pass in a cell with a key of column index. And then we will check if that column has a formatter. If it does, we will return the formatted value for our row with that column key. Otherwise, we will return a string of that row with the column key of column key. Now I can save this and come over to our index.client.tsx, and we can import our table. Then I'll scroll all the way below our chart here. Then I'm going to create another dashboard group that has the same styles here. And then I'm going to include a table that is going to have columns, a title, and some rows. So I'm going to separate these out to make it easier to read. And then we're going to start with our title, which will be top pages. And then our rows will be pages. And then our columns are going to be our key page, label page. Then we'll have a key of visitors, label visitors, and a formatter of format number. Then we'll need a key of page views with the label of page views and a formatter of format number. And then finally, a key of bounce rate, label bounce rate, and format percentage. We can do this again. We're going to copy and paste this table. And instead of pages, we're then going to pass in sources. And then we'll change top pages to top sources. Then we need our source, which will be of label source. We'll keep our visitors and our bounce rate, and we'll change page views to visit duration. So we'll change label here as well, visit duration, and we'll set our format duration here. So we need a format number for our visitors and format percentage for our bounce rate still. And then finally, we'll paste one more time. This will be our custom events and goals. Then we can set our rows to be events. And then we need our goal, which will have a label of event. We'll keep our visitors the same with the same format number. Then we can get our events, which will be a label of total events, and we'll format the number. And then finally, a conversion rate. So we can change this from bounce to conversion rate, and we'll format that percentage. And so we only want this, though, if we have events and our event's length is greater than 0. If that's true, we can get our table back. So now when I save this, I can scroll all the way down, and now we see we have our top pages for my analytics, my top sources, and then finally my custom events and goals. Now that's all of our data in our view. But of course we can't expect people to go to /admin/analytics. We want a way for our editors to be able to just click into the analytics dashboard. So let's add this to come after our navigation links. And we'll do this by creating another directory in our components directory, and we'll call this one after nav links, and then of course index.tsx, and we'll create that file. Then this is going to be a client component, so we'll use client, we'll import React from React, and then we need a couple things from Payload's UI. So I will import our nav group as well as our link from Payload CMS UI. Now for the client side of things, we need to get our use path name so we can deactivate the link if it's currently selected. So with all of those imported, we can now export a constant called after nav links and set it equal to a function with no props. We'll get our path name and store it in path name. I'm going to set an href, which will be admin analytics, and then we'll check if this is active by checking if path name includes href. So I can do our includes method and check for href. I'll then return our nav group, and our nav group needs a label, which will be views, and it needs children. So I'm going to pass in a link, and this link is going to have an href of href. Then we will include a class name, and the class name will be nav link, and then we'll have an ID of nav analytics, and then finally a style of cursor, which cursor will check if it's active. If it is, we'll return pointer, otherwise default. And then finally our pointer events, again checking if active, return none, otherwise auto. If active is true, we can return a div, which is actually going to be a self-closing div. And this div is going to have the class name of nav link indicator. Then underneath this, we need a span that will have a class name of nav link label. And this span will have the label of analytics. Then we can export our default after nav links constant, hop on over to our payload config, and underneath our views here, we can include our after nav links, which expects an array. And then we'll pass in a path of components after nav links. Then we'll need our index.tsx file. So I can save this, and then I'll run payload generate import map, and then pnpm dev, and then refresh. And then once I'm refreshed, I can go back to our collections, and then I can see that I have two analytics actually. So I'm going to come back over to our after nav links index.tsx, remove the analytics there, and then include our span analytics in the link like it's supposed to. So now I can save this. Now I see that I have just one analytics that I can click on, and then now it's no longer selectable here. I'll also change default to auto, so we get that nice pointer when I'm hovering over the link. You've now got a native, modern, sleek analytics dashboard living inside your Payload CMS admin UI. We wired Plausible into route handlers validated with Zod, fed that into a custom admin view, and rendered it with Recharts, so your numbers show up exactly where you actually work. It's provider agnostic and self-host friendly, so you can swap in any analytics source like PostHog or Umami or Google Analytics and keep the same plumbing. If you found this video helpful, please like it and share it with others who might also find it useful. Check to make sure you're subscribed to my channel and receiving notifications so you never miss when I release more content about Payload CMS, Next.js, and Tailwind CSS. If you'd like to see my content ahead of when it goes out to the public, consider becoming a paying member of my channel as well. Among other perks, you do get access to some of my videos before they actually go public. If you're tired of trying to keep up with all of the industry news for web development, consider subscribing to my newsletter, Next in Dev, where I'll send a bi-weekly overview of all the news from across the web development industry in a way that's easy to read and easy to digest. There's a link to that in the description. If you have suggestions or questions, please leave those in the comments. I'd love to hear from you. Until then, I'll see you on the next one.